Hello, in this lecture we will learn how to build attention-based data transformation method using neural networks. As we have discussed in the learning materials, the main motivation of building this mechanism this is an extract from the materials on the learning website. So we want to build from layer to layer different representation of the data so that the relevant information can manifest themselves when we train the model so that to adjust the behavior so that the model will finally output some desirable result from the input. And along the way, the information and the format in which the information in the data is represented will automatically adjust it in such a way that is facilitated revealing the desired target information. And the construction of this transformation the most straightforward way is just to take the weighted sum from the input to the output. And in this lecture, and if you read the learning materials, we introduce a new mechanism that the one-step transform is formed using a mechanism called self-attention, in which we for each output, each unit of the output, we calculate the relationship between this unit to the other part of the same data instance. So we consider the relationship, and we use the computed relationship to combine the simply in this way linearly transformed other parts, but using the automatically discovered weights rather than those weights that has been adjusted during the training time and remains constant in the test time. So that is the motivation of the transformation neural, the attention-based networks. To compute, and here in this short video, I'm a short video series. I'm leading the steps. I'm tutoring the steps of how to build such mechanism into actual data model. So let's review the computation. Okay, so we have said the relationship between two parts of the data is calculated using the inner product. Well, this is not fixed. You have different kind of mechanisms to measure how one part of the data is related to the other part. By the way, by part, we realize that mathematically as an object in a digital computer as a vector. So we compute the inner product of two vectors and consider that as the relationship between two parts in one data instance. Okay, and we use that as weights, and use these weights to combine all the parts of the data to form another layer of transformation. Okay. So this is these are two illustrations of the image and text example, how the attention mechanism works on those examples. Basically, the main point here is what do we want to consider as one part in one data instance. From instance to instance, we consider the information between two instances are independent, but within an instance, such as the pixels within an image, we consider they have some relationship between each other to be discovered and exploited. So, so much for the introduction and motivation for the attention. mechanism, and please read the materials and the opening part of the code notebook for more information. And from the next video we will dive into the code and see how this attention mechanism works at its core.